Hey everybody, welcome back to the shop. I'm getting back on our big lathe project here where we've got these steel blocks that we have to drill and bore. Now I do have a couple of videos previous to this one here where I've got our American Pacemaker coolant system patched up, hooked back up and working again properly so that we can use flood coolant. We've got a big spade drill that we're putting in the tool post here to drill this and then bore it to size. And now that we've got the very first one finished, I've got the process proven. I know that it's going to work. Now it's a matter of getting the rest of them done. I do have 15 of these total that we're going to be machining. So I'm actually doing this job for another machine shop. And this is for Donald out in Colorado, Iron Eagle Machine. It's a job that he's doing for one of his customers, but this process here of putting this bore in this block was something out of his capacity of what he could handle. And surprisingly enough, he called around to several other shops. Nobody was interested in the job. Nobody wanted to take it on. And you know, that's understandable. A lot of places, they're not job shops, they're running production and they don't want to set up to do stuff like this. So Donald's been a viewer of my channel for a long time. And when he couldn't find somebody there in Colorado to help him get these blocks machined, he reached out to me, showed me some drawings, said what he needed done, and asked if I'd be interested in doing it. And I looked it over and knew that this was something that even I couldn't do in the Flex CNC or even the Miltronics over here, just because of the size of the workpiece. If you're having to stand this up, you know, you're taking up a lot of your Z height there, your travel, and then the large drill that needs to go in there. You just have to have a big machine in order to do something like this. But I thought that the American Pacemaker was going to be a good machine to get this done. And now that I've got the first one done, I've proven that it actually is going to work. So I ended up having just enough swing on here with our American Pacemaker. This is a 20-inch swing lathe. And with the one offset jaw like this here, you can see that I actually had just enough room to be able to swing this block. All right. So it's working good. Now we need to get back on these and get them finished up. So I don't know the specifics of how these blocks are actually used at the end product there. And Donald's customer asked that we didn't reveal that. They don't want their name out there. Totally understandable. But Donald said that, you know, showing that what we're doing here is perfectly fine on the video. They had no problem with that. They just wanted to keep what they're used for and who it belongs to private. So we're going to respect their wishes there. All we're focused on is getting the hole drilled, get it bored to size, getting all those done, and getting it back to them. So I do want to point out, we talked about this in a previous video, the block is not finished, okay? It is merely just roughed out, and Donald put some of these holes in here to get that part done. He did drill a center hole here for me to be able to line up on and get it indicated with. But the outside of this, you might think that it looks a little rough, and it is. And that is unfinished. And the reason why he left that is so that I would have material here to chuck on in this lathe, because the way this thing is shaped, you might be able to see this little line milled in right there. All this material back here is actually getting milled away, and this will end up being a through hole. There's a spindle that goes through here with a bunch of bearings, and you got the shafts that stick out. So in order to be able to put this in the lathe, we needed material here to chuck on. But he decided to leave it oversized. He wants to go back into this and make some finish cuts on here so that you have a really pretty finish whenever this is completed. So just wanted you guys to be aware. I don't even have to have the brass shim stock here chucking on it. I'm doing that purposely because when you're trying to indicate a big heavy workpiece like this, if you don't have some kind of brass or copper or something underneath there, it tries to gall and it doesn't want to move very well on you, depending on how much you're having to indicate and move the workpiece. So that's the only reason I'm using the brass shim stock, is to allow me to easily get this thing indicated where we need to be. So I do have a couple of drawings here that I can share just to kind of see. This was the first one, just kind of show the overall of what Donald needed. Just a rectangular block with an 85mm hole bored in it right there, which is 3.345 inches. And that is, there's a couple thousandths difference on what the print is and what we actually finished this at. That's just a target number there. We have bearing, we actually have a bearing spindle system that slides into this, and they want it a slip fit. They do not want it pressed. So our target is 1/1000th over what the bearings are measuring, and that's what we're going to be working towards on that. But here is another drawing, and it doesn't have anybody's data on here, but this is a drawing of what the part will actually look like at the end once it's completed. Once Donald does all his machining on there, there's a dovetail on here. You've got some tapped holes and things like that. But that's what this workpiece will look like when this is finished. Moving on, what I'd like to do before I take this first one out, I want to go ahead and make some counterweights to go on the chuck here. You can see that you can see how all of our offset to this side, it's kind of heavy. So I've got some solid steel rounds I'm going to drill and bolt over here on this side of the chuck, and hopefully we can get it kind of dialed in to where it's counterbalanced pretty evenly and we don't have this offset swinging through here. It'll work just fine, but it is easier to indicate it whenever it's counterbalanced properly, and especially when you go in there with the boring bar, you might want to run a little bit faster speed. So that's the next step. Let's go ahead and get some counterweights on the chuck, and then we'll move on, get the next one indicated, get back to drilling and boring. These are some of the steel rounds that I brought from the home shop here that I'm going to use a couple of these for a counterweight. I wasn't sure what we needed exactly, so I grabbed a few. I think we're going to start with 2 of these right here. This is my scale. I was going to show you that I've got 2 of these that weigh 13.5 pounds. And I think we're going to start with these 2 here. Put that one on there, and you can see that coincidentally they both weigh 13.5 pounds. I do need to go put them in a lathe and drill a hole through here, both of them, so we get them bolted onto the chuck. So I think I'm going to start with these 2, get them mounted onto the chuck, and see what that does. And if we need to add some more, you see I've got some more pieces right here. This is a piece of ductile here. If I need to cut it, we can do that. But I think between these counterweights right here, we should be able to get that chuck counterbalanced. Our counterweights are going to bolt on right here. We'll use these T-slots and just use some of our standard 5/8 hardware with a T-nut and a stud, and we'll use a washer and a flange nut, but we'll just have these studs on there like that. Our counterweight will get bolted on right there, 1 on each side or 2 on each side, whatever we need to do to try to get this balanced properly. So all I'm planning on doing is just cleaning the faces up, make them look a little more presentable and nice and flat, and then we'll drill our hole through the center. Just checking the tool for center line, and it's good. And we'll just clean the face up. Just for fun, we'll weigh them again so you can see. 13 pounds. £26. Pretty equal in what they weigh there. Don't know if this is going to be enough, but we're going to give these a shot and start from there. Okay, let's get our counterweights bolted on here and see what kind of improvement that we're going to get on this counterbalancing. All right, what you guys think? Is it going to work? Let me Just take it to neutral. All right, still a little bit heavy there. Big improvement though. There's not a lot of effort that it takes to pull that heavy side on around. So it doesn't need much, and it's a huge improvement over what we already had there. So this may just very well work. I'd like to take, I've got one more of these that are thinner. Let me see if I can just kind of hold it on here and see if that third one, the amount of mass that it has is going to correct that if I was to add a little bit more to this here. Go grab that one. There's that other third piece that we got without trying to manipulate it too much. So just want to kind of hold it on there and see. Well, I'm putting a little bit of pressure in it, but it feels like that might actually balance that out a little bit better, having about this much material total. Won't quite stay there. I was just going to see if it would fall, and it's trying to. Yep. So I've got that other piece of ductile iron over there. This one's going to be a little bit tricky to cut in half. Oh, I was thinking if I had two pieces, you know, half this thickness, drill the hole, and we can bolt those on there too. That might help balance it out just a little bit better. I believe I have our counterbalancing just about dialed in, extremely close. I took that other thin piece of 6-inch stock, I cut it in half in the bandsaw, faced it, drilled our 5/8 hole, got them bolted on there, and it seems like it's very, very close now. In fact, let me, we'll put it in neutral. Come on, that neutral is real fine to get in there. So there we go. All right, here we go. This is neutral. That's about as balanced as I can get it without actually being able to measure it in some way. But you can see it's not trying to fall back down with it in neutral. Neither this offset here or this offset. Pretty well balanced. So that worked out really good. We'll go ahead and put it back in gear. 126 RPM, so you can see it running. that is looking good. So we have our counterbalance issue fixed now. That shouldn't give us any more problems. So now we can kind of move on and go ahead and start working on our second workpiece. And what we'll do, let me go ahead and shut this off here. What I'd like to do is show you how we're going to indicate the tool post here, the tool holder, each time I want to go ahead and go in here and drill the next workpiece. My plan is, now that we have the first one established, I'm going to put that collet chuck in here. We're going to put our coaxial indicator, and I'll be able to indicate this hole to be sure that our tool post is exactly center line in this way and up and down there as well. So I've got this ER40 collet chuck from Pee Wee Tools. We're going to go ahead and put it in the boring bar holder here, and I have it adjusted a very close fit so that there's no side movement in that, but it allows me to go ahead and spin that. So we're going to put a coaxial indicator here, indicate the bore, but since it sticks through the holder, I can just simply rotate it just like you would in the milling machine. If you're trying to line up a hole in the milling machine using the coax, it's the same exact way. But this time, since we have this already finished, this puts us on our true center line right there. When I did this in the previous video, we actually indicated that center there. So we had this opposite on the other side, and I was indicating the OD of that center, which got me really, really close. But after that job, I actually put the coaxial in here once I was done boring it and lined up the center, and it was off a little bit on our height there. So that's telling me that our tailstock is slightly low, but it's still good. But now we'll just go ahead and line up on our existing bore right here, and that'll put us dead nut center for our next workpiece. So we'll get our coaxial indicator set up here. And this should be good because I've already got it indicated, but I want to go ahead and show you guys what we're doing here. I'm going to use the long feeler. I'll just hold it for our video here and do our rotation. Yep, so we're off in this axis, a little bit x-axis, just because I've been over here fiddling with it and working on the machine, so I need to adjust it. So I'll go ahead and make that adjustment now on our cross slide and get centered up where we need to be. It's only off about a couple of thousandths, so I think I've just, like I said, I've been over here bumping on it. Let's go another thou. Just moving the cross slide. A little bit more. I'm just moving it that way. All right, so up and down is off a little bit. About 1/1000 thousandths. That one gets a little bit more tricky. Let's see if we can go ahead and get our up and down adjusted. I didn't move anything, I just wanted to see if it would stay. So we'll loosen it up. This is going to be really, really tricky. Just going to move it just ever so slightly on that adjustment screw there. Let's see if we can get it a little bit closer. Loosening the tool post. So that is that's under 1/1000. Let's see if we can do that one more time. Get any closer than that. There we go. So I'd say that's 1/2 thousandths. And that should be good. So now that that's where it needs to be, we'll go ahead and lock this back. And now we're indicated dead center. So that's what I'll do each time. Once we finish getting one drilled and bored. I'm going to set this coax back in here, make sure that we're in the center where we need to be. Hopefully up and down will stay pretty consistent, but things may change just slightly. All right, and that's going to be it. So next step, let's go ahead and get this one out of the machine. We're going to put the next one in there. We need to get it indicated, and I'm going to show you how we'll do that next. Okay, let's get our next workpiece in here. So we're going to focus on 2 jaws only whenever we're loosening this chuck up to put the next one in. I get that one loose there. And then I think I'll go ahead and put it in gear to help keep it from trying to move on us. Now we're going to use a magnet to pick this up and set the other ones in there. That's the brass shim on the back side. There we go. So my plan is we'll set it right over here on the mobile skyhook cart, and we'll use the skyhook to transfer this down to the pallet over there, and then we'll pick up another one, bring it here, transfer from the skyhook over onto the jib crane here. All right, there it is back in where it needs to be. We'll go ahead and start putting our shims. I know I need one on the bottom and the back side there to kind of get things moving. If I didn't mention it before, because I can't recall if we talked about it, but the brass shim stock I'm using isn't necessary to prevent marring of the surface because this isn't finished. That has to all be milled off. The reason why I'm using brass shim stock is because it's easier when you're trying to indicate these heavier pieces like that, and you want to make sure you get it really good and tight. It's just easier to slide across some brass or copper or even aluminum, something like that, when you're trying to get these things indicated in. If it's really close, it's not a big deal, but if you're trying to move it, you know, 1/8 of an inch or even more, trying to get it centered up on there, those jaws will start digging into that steel, making it really hard to get indicated. So it's just to make the indicating easier. And if I had to protect the finish on it, I'd be using it that way as well too, for that reason. Just trying to push it flat against the chuck. Looks like it's there now. I'll come back in and put our brass shim stock on the top. Now that we've got it held in there with those top and bottom jaws, we can go ahead and get the magnet off of it. So looking at the end of the block here, you can see that there's a center hole drilled here. This is the hole that we've got to line up on that we're going to indicate. So I'm kind of jumping forward here because I need to push it back a little bit, and the easiest thing to do that is use the tailstock. This is what I'm going to be using to indicate it. We're going to run this between centers. So this will be on the live center and the tailstock. This will be in the center point drilled there, and then we'll put our dial indicator here and indicate it. But we can go ahead. I don't want to move this tool post. It's right where it needs to be, so we're just going to go ahead and run this through here like that and bring this up to the center. And I'm going to bring the tailstock up and push on this, and we can just use the tailstock to push this block all the way against the chuck there. Just like that. And we'll go ahead and just lock the tailstock in place, and I can loosen those jaws slightly, and we should be able to crank this in there and push it back. Let's see if we can get this pushed back now. I'm going to go ahead and loosen these up slightly. The first one I put in here, I didn't really have that issue, but on when we go back in there with some more, I may just go ahead and do this once we get it in there to keep it pushed back to begin with, and then snug up the jaws there. I'm just going to loosen those slightly. Let's see if that's enough there. I'm going to go ahead and crank the tailstock handle, and it's pushing back. There we go. All the way back. That's good. So go ahead and tighten these guys up. All right. First thing we're going to do though, this is where we're going to be indicating. You can see it running out. That's why we got the brass shim stock in there, is because you got to get this thing moved around. But I want to make sure that it's running nice and straight. So the first thing we do is actually indicate the side of the block on two sides there, bump it and try to get these perfectly aligned, and then we move back to the center and get that indicated there. So I'm going to go ahead and take this off for now. We don't need that yet. And you can see our balance is off a little bit now, and I was concerned that it was going to do that, but it shouldn't be too bad. Now that this has still got a solid piece in here that's not machined out, our weight is off just a little bit. Let's see where it's at. So it may be these guys here. But I'm not going to mess with it. I'm just going to leave it alone. It's not very much. It's only a few pounds, I think. So let's get back to indicating. All right, got our indicator set up. Let's just run it down and see what it's looking like. So it's dropping off. So it's high on this side, right at 30 thou. I'm going to go ahead and give it a bump and see if it's, get it moved a little bit. I moved it a little bit. This can get a little finicky if they don't want to cooperate. I can already tell you the first one was a little easier. Sometimes you got to move it to the top so you can get a little bit better hit on it. Go ahead and check this other side. See how close that one is? That's only 3 thousandths. Another thing that could be happening to me is the back of this back face may not be milled perfectly square to the side that I was indicating. Remember, we pushed it all the way back, so it could be off just a little bit out of square. That's not too bad. I'm going to give it a little tap on this side here. That's within a thousandths on that one. So let me check this. We'll do this side next and see how square it is. Could be just the back face that's throwing me off. Got to clear that hole. Yeah, see, it ain't near what that other side was. Only a few thousandths. All right, that's on +3. That's on 0. About 3 thousandths. Within 1 thousandths that time. So I think we've got it squared up. I'm gonna get me a drink of water because I'm thirsty doing all this, and then we'll go ahead and start getting our center hole indicated next. All right, now we're gonna indicate our dead center between centers. Run our tailstock back up. Just like that. And you really don't need to tighten the tailstock at all. I just barely snugged one of those nuts back there. We'll go ahead and put our dial indicator right here on this ground section of the center. It's going to be out quite a bit. Way more than what it should have been. Way more. But we'll go ahead and get it. It shouldn't have been out that far. All right, so low on this side right here. High on this side. So I'm going to go ahead and start with this. Shim needs to go up in there better. And we'll go ahead and start tightening our highs. Loosen your lows, tighten your highs. So the side to side, this side and this side's got to move first. I just usually loosen it until just before that shim tries to slide out of there. And that'll get you a pretty good movement each time. And we got it down to about 1/8 of an inch. All right, now it's this side and this side. So let me make sure that it's tight on our high side. And go back to our low. All right, now it's back to these sides. Let's see, we got about 20, 30, right at 30 thousandths. Low, high, low, low, high, low. Getting real close now, so you got to do smaller movements and try to get it tighter. So now we're within a couple of thousandths, about 3 thousandths is where we're at. And from this point, I want to focus on just trying to tighten the jaws instead of loosening them, because we got to make sure this is really good and tight for what we're doing. About 1 thousandths and a half. This is your high. I moved it a little too far, but that's good because I want to make sure these things are tight. This one's high there. I can't really get that one anymore, so I may have to crack the low side loose. 55, 54. So you're only talking 1/1000th of an inch, but I really want to try to get this as close as we can. Been indicating over 4 minutes now. I know this can get, these indicating segments can get a little long, especially for something like this, but it's kind of involved. It takes a bit to show it. So hopefully some of you guys like it. I'm still within 1,000, so I'm going to keep tweaking this, trying to get that last thousandths out of it. It's a 1/2 thousandths. Whew. I think that's going to be good enough. All right, here's a little better look at our finish. So the center is indicated, but what I need to do is go ahead and double check our sides. I'm going to go ahead and run the indicator down this side and this side here just to make sure that it's not kicked at an angle. You still got to verify that these are nice and straight. If it's not straight, you got to repeat what we did, kind of get it bumped around, then put your center back in here and get the center point running in the center. Just verifying that we're running nice and straight again. Nice and straight on both sides there. Remember, you get down to the last few, just tighten it if you can. That's within a 1/2 thousandths. So what I'll do is go around all 4 jaws here. Let's make sure they're all tight. Let me move the camera out of my way. I've got this chuck wrench with this offset handle. It's got a ball detent in it, so you can get you some leverage out here for this stuff like this. It's tight. That one's tight. Barely any movement on that dial indicator. It's within a 1/2 thousandths of being true. So we're going to call this indicated, ready to drill. All right, guys, if you didn't see it on the previous video, this is our spade drill that we're going to be using to drill our hole. This is a 3 1/4 diameter spade drill, high-speed steel tip that's on here, and it's good for 10-inch depth of cut there. We're only going just a little less than 8 inches. I go about 7.5 or so on our depth, and it proved to work really well on the first workpiece there. And funny enough, this is actually my first spade drill that I've ever owned or used, and I thought it worked really well. So we have this slip collar here that we can plug into our flood coolant. So we'll have some flood coolant coming out on that, keeping everything nice and cool and lubricated during the cut. And then this sleeve on the back, this is a number 5 Morse taper sleeve that fits that boring bar holder that you've already seen on the machine. This is a 63 millimeter OD. The inside is a number 5 Morse taper, and it worked really well. So we'll slide this up in that boring bar holder, tighten it up, and we're going to be ready to drill. So I've got this, the first one that I drilled, I indexed the drill so that both of the coolant holes were parallel. The reason why is because I really don't have a lot of pressure with this pump that I'm using, and I wanted it to come out both holes there. When I had it kind of positioned more like that, it was trying to come out of the lowest hole, and I want to try to keep that coolant equal there. So we're going to run it somewhere about right there, and it worked really well. All we got to do is take and tighten this guy up. I've got a ratchet to make sure I get adequate torque on these guys. That was one of my fears doing the first one, was this actually spinning, but there's a lot of clamping pressure on this guy right there. So that is it. All we got left to do is hook up our coolant, and we're going to be ready to drill. I've got this little hose right here with our quick disconnect to hook up our coolant, just like so. Got our ball valve here to control the flow. And when we're drilling it, I'm just gonna have it wide open. Okay, we are ready to drill. I brought my drill tip up manually here, and it's lining up with that center hole perfectly. So we're ready to roll. I'm gonna run 126 RPM. On that first one, I was running 106. So I'm gonna bump it up another 20 RPM. One reason is this gear train right here seems to be smoother in this headstock. And then the other thing I was going to point out, we're going to be running a 6,000th feed rate on this. That is about half of what Allied Machine recommended. They told me anywhere from maybe 10 to 12 thousandths per revolution should be okay, but that just really depends on the setup here. This isn't the same setup as if you're in a big machine spindle, you know, a big old milling machine, or even a big radial arm drill press, something like that. You don't have quite as much mass as on a big mill or a drill. So we backed off. Whenever we were doing our 6 thou feed, I thought it looked and sounded good. We were getting a really pretty chip. In fact, there's the chips from the first piece that we cut. All right, so let's get this thing rolling. Probably gonna be just a little chattery until we get our full diameter established. That's how it was on the first one. Here we go. I'm gonna bring it up. I wanna eyeball this as we go into that center there. All right, go ahead and engage our flood coolant. And we're gonna engage the feed and let her rip. I'm backing off. I'm not getting the same consistency as I did the first time. I think I'm running 126. I'm gonna go back down to that 106 RPM and see if that will help eliminate that coloring of those chips there. Okay, 106 RPM. I thought the first one did beautiful, so I want to try to mimic our first results. Engage feed. Okay, I think that's going to work. Not quite as blue and purple coming off some of those chips there. I'm taking the drill into that yellow mark on the drill. It's about 7.5 inches. I'm just going to visually line it up with the face. Once that mark disappears, I'll disengage it. All right, so there's our second hole drilled using our new Spade drill. And as you saw, the system actually works pretty good. Once you get it dialed in where it wants to be, it's gonna work pretty well. So I think that our combination of 106 RPM and then running a 6-dial feed rate over there is working good for my machine, my setup, and the rigidity that it has to work with there. We'll take this out, and now we've got I've got a 2-inch boring bar I'm gonna set up. So we'll go in there and finish that out. We don't have a lot to take out. Just under 100 thousandths is what we're gonna be boring to get that to size. All right, here's our boring bar. This is a new one that I got from Walter. It's a 2-inch diameter. I've got it in one of the boring bar holders. I am using one of my sleeves that I made to adapt it up to 2.5 inches. So we're gonna run this. We've already got our depth set. This is a number 5 insert. So this is a 532. Hopefully that's gonna work out pretty good. I'm trying to gain a little bit of rigidity over the first one that I did. I was using an 1.5-inch bar, and I wanted something fresh and new because all those bars that I got are used and wore out, and I just wanted to start with something fresh. So we got the 2-inch Walter there. So we'll get our depth set. I'm just going to take it all the way to the end there, which with a scale measures 7 5/8 to where the drill stopped, and then we're going to be taking this to 3.347 inches is what we want. They would like a very light slit fit on the bearings. I think I mentioned that earlier. So we're shooting for about 1/1000th over what the bearings measure, and that's at the request of the customer. All right, so we'll get rolling on this now. I went ahead and added one of these quick couplings here like we used on our drill bit, so we can attach our flood coolant there. First one was right around 3-inch 260. This one's measuring 257, about the same thing. So less than 100 thousandths to take out of it. Now that we've got it balanced well, we can kick our RPMs up a little bit for this boring op. I'm gonna try 330 and see how that does, and we've got it set at a 10 thousandths feed rate. Got those counterweights on there nice and tight, so they should not fling off. And first thing I want to do, just to verify that I've got my link set right, I'm going to go ahead and run it all the way up in there. 7 5/8. I should have the bar set to where we can go just up to that face with about 1/8 of an inch and be kind of touching the very back right there. All right, and then what I'm going to do, it looks like my indicator is still lined up. So we have our depth set there, and we've got our first 0 on the mag base indicator right there. Well, that didn't work too well. Let's just slow that down a little bit. There we go. It's gonna make a mess. It's gonna make a big mess there. I just slowed it down where we're just got a little bit going in there. I've got my dimensions and our tolerance written down on that sticky pad there. Keep that over here on the lathe for reference. And I'm just gonna make a couple passes and sneak up on our finish here. Using our Starrett telescope gauge and 3 to 4 micrometer here. 3.311. A couple more passes and we'll have it where we want it. Our finish is looking pretty good, minus the drag mark coming back out of there. I got one more pass to make. We've got about 22 thousandths to get it to our size, so we're going to dial that in and make our finish pass. It's got a nice finish. Let's see if I hit my size. Looking for 347. I'm within a tenth or two of being where I want it to be. Looks like maybe 1/10 under. 346 and 9/10 where I measured that there, which is good because the bearing is measuring 0.346. So they wanted a slip fit. That's why my target is 0.347. They were just saying 1/1000 slip fit, maybe 1 to 2 thousandths is what we wanted. So I was giving myself that 1/1000 clearance with a 1/1000 tolerance over that. And I fell within where I wanted to be there. So that's going to be good. And I will double check it here. I usually mic it 2 or 3 times just to kind of verify. But I hit it good on that first measurement there. Felt really good. Exactly the same. 346 and 9/10. It looks good. The insert did a good job. I was really worried about that nose radius. It didn't give me the chip control that I wanted, but I think it's going to work, and we've got a nice solid boring bar there to help give us a good finish in that. One last thing to do, we need to put a little chamfer on that edge there. Got a brazed on tool. Well guys, that is the process there for drilling and boring our steel blocks. So I've only got 13 more to do. I got 2 of them finished. So it's going to be a repeat. Everything you just saw, getting the workpiece in there, get it indicated, get it drilled and get it bored. The next step from here, remember back whenever we were getting this indicated, so before I actually move this and take this out, we're going to put our boring bar holder back in the tool post, put our collet chuck, our coaxial indicator, and I'm going to get this bore centered up so that our compound, our cross slide is back dead zero for our drill, and then we'll just move it back. Once we get this indicated, what I do is I've got this mag back indicator right here, and I put this over here. Works really well for get the chips off the magnet there. It works really well for setting a 0 on this cross slide. I set a 0 on the compound, a 0 on the cross slide dial, and then I set that to 0 there. I've got 3 references on which to get that in case something gets bumped or shifted before I go in there with that drill. So anyway, that's what I'm going to do now. You guys already saw that. I might give you guys some highlights. This job is probably going to, I don't know, it's probably going to take me all week to get all these things done. It does take a few hours to get all this knocked out. And now that I've got my system kind of in place and we've got everything ready to go, I'm not wasting time making counterweights and finding tooling and stuff like that. We should be able to just kind of continue on and get these guys knocked out. But the drilling is definitely very cool, very interesting to watch. So we'll probably get a little bit more of that, whatever that, anything that I think you might find interesting to kind of help fill out the video, and then get all these guys done, and we'll wrap it up and show you the finished product at the end there as well. Okay.